Okay, so here we are. We're going to be talking about naming chemical compounds. So our first type of compounds that we're going to need to name are ionic compounds. So there are a few different categories of chemical compounds. Each different category has its own set of naming rules. The categories are ionic compounds, molecular compounds, and acids. So before being able to name these compounds, we need to have some understanding about atoms and ions. And now that we know about the atom, let's focus on ions. So ions are particles or group of particles that have a net charge, either positive or negative. Metals give away electrons and become positive ions, like there we have sodium, calcium, and iron. And nonmetals take electrons and become negative ions. With this information, you need to make the correct ion using your model and take a picture of it. Bring this picture as the final portion of your atom model assignment. Some metals, these are multivalent. Multivalent metals have two different possible charges. Charges for ions are found on the periodic table of elements. So, ionic compounds or salt. An ionic compound is a metal plus a nonmetal or a polyatomic ion. So to go from the formula to the name, you name the first ion, and then brackets for the charge if it's multivalent. Then name the second ion and add the ending "-ide". So in example, I'm going to have a metal, brackets if I need it, my nonmetal, and then end in "-ide". So for example here, I have AlCl3, so aluminum is my first metal, or is my actual metal. Chlorine is my nonmetal, okay? So it turns into aluminum chloride, okay? Here I have iron 3 oxide, okay? And now iron has two different forms. It comes in the Fe2+ or the Fe3+. If you look in your periodic table, you'll find both of these. Essentially, what this is the reason why it is iron 3 oxide and not iron 2 oxide is because the charges are actually coming from the periodic table. Okay, and what we do is we do this crisscross motion here where we take the charge of the iron and we put it as a subscript to the oxygen, and we take the charge on the oxygen and we put it as a subscript for the iron. This is just showing the charges amounts, okay? And this actually means that we're using iron 3, all right? We'll talk a little bit more about this in class. So, molecular compounds. Molecular compounds are made up of non-metals only, okay? Very important. All of the electrons are shared and therefore no ions are formed, hence no charges are involved, and we must use prefixes when we name. So to name these, we have to go from the formula to the name. We name the first element, including a prefix if necessary, and then we name the second element with the ending of "-ide". Okay, so in effect, it goes prefix, first element, prefix, second element, and then "-ide. And the prefixes are found in our data booklet. So for example here, I've got nitrogen with the 2, so that means I need the prefix here of di. So this becomes dinitrogen monoxide because there is no subscript here, okay? There's no subscript here. That's why it's monoxide. Here we have our lovely carbon dioxide, okay? Carbon, 1, it's in the front, so I don't need to have a prefix. It's not monocarbon dioxide, mostly just because we're assuming there's only one carbon in this situation. So carbon dioxide, and then here we have tetraphosphorus decaoxide, tetra being the prefix for 4, and decaoxide being the prefix, or sorry, deca being the prefix for 10. Then we have acids. Acids always have aqueous as the state and always have a hydrogen. Acids are named using the following rules. These rules are also found in your data booklet as well, and we will talk about how to use these. So for example here, if we saw this acid HI as aqueous, we know that this, if I was naming it as, let me put this back here. If I was naming this as an ionic compound, this is what I would have, okay? Hydrogen iodide, okay? That's my ionic form, okay? And that goes into hydrogen, and then it ends in I, so it becomes hydroiodic acid, okay? We'll go over this a lot in class. This becomes kind of the more trickier thing to be doing here. But these are some pretty great examples. And we'll talk there also about our polyatomic ions, which is something that we have yet to be talking about, okay? All right. So next we have subscripts. So subscripts are used in order to indicate state. A S as a subscript indicates a solid, an L to indicate a liquid, a G to indicate a gas, and then we have AQ, which is to indicate an aqueous solution, which means that the substance is dissolved in water, which is really, really important for chemical changes. So bases are easily identified because they always have an OH group. You are always going to see that in the bases, and they're named the same as ionic compounds, simply because they are ionic compounds. Okay, common names. So not everybody is a scientist, so many chemical compounds are often identified by a common name. And these names are easier to use, and they have existed since before the International Naming System was created. These common names, chemical names, and chemical formulas are to be memorized. All right, so there it is. You need to know the common name, the chemical name, and the chemical formula for all of these mesmerizers. So each one of them you need to know. Mostly the common name and the chemical formula. We'll be doing a lot of practice with this, but seriously, the best way to do this is a great idea is to make some flashcards. You're going to have the common name, and on the other side, the chemical name and the formula. Okay, this will help you to remember these and study for your tests. If you have any questions, we're going to be talking about this come next class. Thanks so much.